Hi everybody, this is lecture 3, part 2, cumulative frequency polygon. So by the end of this lesson, you should be able to draw a cumulative frequency polygon and you should be able to study the polygon. Okay, so let's consider the same example of continuous quantitative data, our cholesterol data. Yeah. So here we have the class boundaries and the frequency. Yeah, there are two data within this class. There are two data within this class. So that's the same example we're going to consider. And in now, what we're going to see is we're going to find the cumulative frequency. As the word indicates, cumulative frequency is nothing but adding up the frequencies. Okay, guys. So we're going to find the cumulative frequency. So let's now add the frequencies in each class to give a cumulative frequency for each class. Okay, so let's start adding. So what is the first? Yes, there are only two data until 3.95. Until 3.95, we have only two data. Up to 4.45, we have 2 plus 2, 4 data. Up to 4.95, we have 2 plus 2 plus 4, 8 data. Up to 5.45, we have 8 plus 8, 16 data. Then we have up till 5.95, we have 16 plus 6. So we have 22 data. Then until 6.45, we have 2 plus 2 plus 22 plus 3 is 25, correct? I'm just doing it just because I want you to understand what we are doing here. We are just adding the frequencies in each class to get a cumulative frequency for each class, okay? So until 6.45, we have 25 data. There are 25 data less than 6.45. And 5 plus 25 is 30. So there are 30 data up to 7.45. Okay, there are 30 adults whose cholesterol level is below 7.45. There are 8 adults. Let me take a different pen. There are 8 adults whose cholesterol level is below 4.95. Are you getting that? It allows you, cumulative frequency allows you to see how many adults have cholesterol level below the upper class boundary. So there are 22 adults whose cholesterol level is below 5.95. Can you see that now? Yes. Okay. So we have our cumulative frequency now, and on the third column, yeah. So the cumulative frequency for a class represents the total frequency, the total number of values that is less than the upper class boundary. So there are 2 adults whose cholesterol level is below 3.95. There are 4 adults whose cholesterol level is below 4.45. There are 8 adults whose cholesterol level is below 4.95. So there are 16 adults. You tell me, guys, whose cholesterol level is below, very good, 5.45. There are 22 adults whose cholesterol level is below 5.95. Very good. So and so on. Yeah. So that's what cumulative frequency helps us to read. Yeah. So there are 2 values less than 3.95 and so on. Okay. Now let me ask you, how many values are less than 5.95? Good. There are 22 values less than 5.95. There are 25 values less than 6.44 and so on. Okay. So now let's see how a cumulative frequency polygon will look. Yeah. So we can represent the cumulative frequencies in a cumulative frequency polygon where the cumulative frequency is plotted against the upper boundary for each class. So on the y-axis, you have cumulative frequency. On the x-axis, you have the upper class boundaries for each class. So you're going to plot upper class boundary. Okay, I should have taken this as upper class boundary, okay? Okay, so you should consider that on the x-axis, not the class, guys, it's upper class boundary. I will correct it on the, see, there it is. So do not take the class, that's why I've shown this here, yeah? Take the upper class boundaries. Take the upper class boundary. On the x-axis, that's your x-axis, and that's your y-axis, okay? Okay, now this is how your cumulative frequency polygon for this will look. Look at that, 3.95, there are two, cumulative frequency is 2, so 1, 2. So I have taken the data point as this, and 3.95 is here, okay? 4.45, 4. So 4.45, and that's 4. Can you see that? Okay. So now, and you plot until 7.45, which is 30. 7.45, it's in between, yeah? And 30, see? But look at this point. What is this point? This is the lower class boundary of the first class, the 2.95. Let me show you here. See, that is the lower class boundary of the first class, okay? That's very important, guys, okay? So the first value, the start point, is at the lower boundary of the first class with cumulative frequency equal to 0. That's a very important point. So you always start the plot from 0 with the cumulative frequency 0 and the lower class boundary of the first class 2.95. That is at 2.95. Okay. The points are joined together by straight lines. Use your ruler to join the points. Please use your ruler to join the points. Yeah. It should be straight line. It's not a curve. It's not a smooth curve. It's a straight line. The curve has a characteristic of S shape. Yes. Okay. So most of your data lies in this interquartile range. Okay. Okay, I'll show you that here. A group frequency table, its histogram, and the corresponding cumulative frequencies are all equivalent. They are all equivalent. Let me show you that. Let's take the same example of cholesterol data. That is your group frequency table. And that's your histogram for the same data. And that's the cumulative frequency polygon. You can see that they're all equivalent. Let me take one class 5.0 to 5.4 to understand this. The class boundaries are 4.95 and 5.45. That is, the lowest value this class can take is 4.95, and the highest value this class can take is 5.45. The class width is 0.5 and the frequency density is 16 and the frequency is 8. Okay, now look at this. We have taken this class. Each can be obtained from one of the others. Yeah, let's see how. Yeah, 5.0425. So that means we are talking from about this class. Okay, about this class. And the frequency density is 16. 16 times the class width will give you 8, isn't it? Yeah. Now this class has got the lower class boundary as 4.95 and the upper class boundary is 5.45. Let's look at the frequency polygon for the same class. See, this class has lower class boundary 4.95 and the upper class boundary is, sorry, it should be here, okay, 5.45. It should be here. It should be in the center, guys. Be careful. Yeah. So that is the class boundary we are talking about here. And look at the value here, the frequency. This is cumulative frequency, okay? That is 8. And here, it is 16. So 16 minus 8. So there are 8 data within this class. It's the same. 8 there and 8 here. Yeah. So if you look at this, all these 3 are interchangeable and they're all equivalent to each other. Yeah. So that's how you can see the relation between the group frequency table, histogram, and its cumulative frequency polygon. They're all equivalent. Yeah. Okay. Now let's see how to estimate quartiles using cumulative frequency polygon. Okay. Okay. Quartiles can be estimated directly from the cumulative frequency polygon. It's a very straightforward job, okay? So here you have the cumulative frequency. On the y-axis, you have cumulative frequency. On the x-axis, you have the upper class boundaries. For cumulative frequency, upper class boundaries, yeah? Okay, let me change the color. Okay, so most importantly, the last data in cumulative frequency will tell you the number of data values you have. Okay, that's very important. So here you have 30 adults. That means the top value tells you clearly that there are 30 adult or 30 data values. Okay. Okay. So now how to find quartile 1? Let's see how to find quartile 1. Since this is cumulative frequency, it's straightforward. Halfway of 30 is 15. So we're talking about this point, 15. Halfway of 30 is 15 because Q2 lies halfway. It's an estimation again. It's interpolation because we are going to interpolate. We are going to estimate between the given data values. Yeah. Okay. So it is 15. So I'm going to extend this there. Okay. Now let's find Q1. Q1 will be 1/4 of the total data values. So 1/4 of 30 is 7.5. So it should be 5, 6, 7, and 7.5 here. Okay. Now Q3 should be 30 times 3/4, isn't it? 75% of the data will lie there. So 3/4 times 30, so 22.5. So 20, 21, 22, so it should lie here. Okay. And now what we do, we have to interpolate a line down, touching the x-axis to find the corresponding value for the quartiles. So each case, the quartile is found by finding the corresponding data value on the x-axis. So you interpolate the line. So like this. So that's your Q1, that's your Q2, Q3. And you can, by interpolation, you can see the values. This is almost 4.89 or 85. This is just an estimation. So even in the exam, I will give you marks for that because it is an estimation, but it should be accurate there. I mean, not exactly. Yeah. And then you have Q2, then you have Q3. So plus or minus the actual value. So because it's an estimation. Yeah. So this gives exactly the same estimation as interpolating a grouped frequency table and dividing the area of the corresponding histogram into 4 equal parts. So in histogram, we did the same, but it's a bit tedious because you have to divide it into 4 equal parts and then find the quartiles. Yeah. Okay, so that's how you estimate quartiles using cumulative frequency polygon. Okay. So we've seen how to draw and study the cumulative frequency polygon and how to estimate the quartiles using cumulative frequency polygon. That's all for now. Thank you very much.